continuing with acids. An acid is something that can, we'll just say donate hydrogen ions. It's a proton donor. And if you remember Arrhenius and Bronsted-Lowry definitions, which we will talk about later in the packet, you'll remember that the Arrhenius definition was definitely had to be hydrogen. Bronsted-Lowry is really more this proton donor definition. But they both apply. And for most of the ones we're going to look at, it's going to be a key if there is an H in front. They use the same prefixes as our covalents. They use mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. With acids with the hydrogen as the cation, the metal, and non-metal as the anion, are named adding the hydro prefix and then an IDE suffix to the end. So these are the ones that are going to be the covalent in the when they're by themselves, and when they're in aqueous, now they're going to be the acid. So remember I said HCl, it would be hydrogen monochloride as a molecule, but in aqueous solution, remember in water, that means we would call it hydrochloric acid. Okay, so next rule, acids with hydrogen as the cation again, it's always the cation, and a polyatomic 8 group, like sulfate or phosphate or chlorate, as our anion, are named by replacing the IDE suffix or the ATE, ATE suffix with an ic suffix. So HClO3 becomes chloric acid. The hydro goes away, it's now just chloric acid. Hydrochloric acid, chloric acid. Acids with hydrogen as our cation and a polyatomic ite group as the anion are named by replacing the ite with an us. So HClO2, let's go back. This is hydrochloric acid. This is chloric acid. This would be chlorous acid. So if we look back at our things, we can go through a name. HCl is hydrochloric acid. H2SO4, that is a 8, sulfate, so it becomes sulfuric acid. ClO2, that is a chlorite, so that becomes chlorous acid. HBr, so if you saw HBr and they told you it was covalent, you should name that hydrogen monobromide. If they tell you it's aqueous and it's an acid, that would be hydrobromic acid. So hydroiodic acid, HI. Anytime hydro, you know it's just a binary. Hydro acids are binary. Chloric, HClO3, and since H is +1 and the chlorate ion is a -1, we can leave it like that. Sulfurous, HSO4, O, so sulfurate is SO4. Sulfurite would be SO3. And sulfurite is -2, just like sulfate. And so that's going to cross that -2 down. Acetic acid, that can be a little tricky. You have to remember either that acetate is one of our polyatomic ions. You could remember that based on, what is it, the one I call choo-choo? It would be the, what is it, C3COO. And you guys might remember that when you see those COOs, that's a organic acid. If you look at that, that would be CH4 or C2H4O2. Let's write it that way. C2H4O2. So another name for acetic acid, remember our 2's, we're going to get to that in organics. 2's are ethyl. So ethanoic acid and acetic acid are the same thing. Let's look at some organics really quickly before we call this page done. Hydrocarbon. It is a molecule with only hydrogen and carbon. All right, I guess the notes are telling me that it's time to be done. We'll start here next time.